Hi there, this is Dr. Embody with Project 10. We only got one more after this. This one is a game. And one of the things that confuses students right away with the games is, are we asking you to build the artificial intelligence to play the game? And the answer is no. What you're building is you're building a program so two humans can sit and play the game against each other. All right, so we get that out of the way. We're going to be using classes, and in this one we're going to use a class that we're providing, kind of like what we did in the lab with the cards class. So this is a different class because this is a different game. And then in the next project we're going to actually create the class. So here we're giving it to you, and the next one we're going to create it. Alright, so let's take a look at this project. The project is it's an ancient game called Nine Men's Morris. The game board looks like this. There are, which makes it nice for this project because there aren't so many pieces, there aren't so many points to place them at. So it constrains the game, but we do have some rules that we enforce, and that's really what our program will do. It will make sure that you can only do the things that are allowed there, and what you really want to do is, like with any game, is you want to play it. So we give you a site, go play it, get a little bit of a sense of how it plays, but it has some basic things that will be familiar. Is that we have some pieces that we're playing with. It turns out that there's 9 black ones and there's 9 white ones. So a total of 18 of these. And you alternatively place them on the board, sort of a natural kind of thing for playing a game. And of course every game has got its quirks. So this game has 2 phases. Phase 1, we're putting the pieces down alternating. Now if you happen to get 3 in a row, and they're either going to be 3 in a row vertically or horizontally, it doesn't count to go around a corner. Like this is not one. This is called a mill. I don't know why it's called mill, but that's the term that's used. So that is not a mill, but this is a mill. And when you get a mill, you get to take away one of the other players. So if you're black and you put 3 in a row, you get to take away one of your opponent's pieces, and you'll be prompted for that. There is a constraint, is that we can take away from these pieces, but we can't take away from those because that is a mill. And we can't take away from the opponent's mill unless there are all they have are mills, and then we can take away from it. So in this case, if I got a mill, I can remove one of these, and that's what we do in phase 1. We're placing these 18 pieces, go back and forth. If we get a mill, we get to remove one of the others. Oh, and in this game, when you remove a piece, it's gone forever. It doesn't show up again in the game. It's just thrown away. So that's phase 1. Phase 2 of this game is when you move pieces. So we don't have any more pieces to put in there, and you can move to an adjacent place. So so for example, I could take this piece and I could move it to there. That's the only place I can move it. This one, I've got 2 possibilities. I can move it there, or I can move it there. And of course you can't move it to a place where it's already occupied, but you can only move it to adjacent places. And again, we alternate, go back and forth, and again, anytime and in this, the point is to try and create a mill so you can remove one of the other players. The way you win this game is when somebody has less than 3 pieces. That is 2. Right? So when the other guy has 2, game's over. So you're trying to remove pieces until you try to form a mill, and that removes a piece, and that's how you go about winning this. Now there's a few other ways where there's a third phase, but we're not playing that version of the game. So anyways, that's pretty much, and then we go back and forth till somebody finally has removed all the pieces. One thing that isn't shown on this one is that suppose I had a situation here. So this is a, whoops, no, let's actually, it's blue. I thought I could get a, I don't know if I get a black one here. I guess not. I'll just use the blue. So suppose that's a black one and that's a black one, and we're in phase 2. And what I might want to do is move this guy to here, and then the next time I get a chance, I move it back, I form a mill. Right? And so I can go back and forth. And in fact, if I had pieces here, every turn I'd just go back and forth, forming mills, and every time I did that, I could remove one of the other pieces. One question that might come up is, suppose I'm in a situation where I add a piece and that creates 2 mills. Do I get to remove two pieces from the opponent? And the answer is no. We can only move one. So every time I create a mill, if I happen to create more than one, doesn't matter. Then I remove one of the opponent's pieces. And that's kind of how the game is played. And so how do we do this textually? Well, what we do is I'll actually run my program. Here's the same game, and it's just done textually, and we've got these blank spaces here that we can put pieces in. All right, and so okay, so how does this game in fact play? Okay, I enter characters, and it will always be a letter first and then a number. So for example, if I want, here's an A and a 1, and that's going to be that spot right there. And so when I'm playing the game, if I say A1, we see that indeed I get an X in there. And now we see that it's O's turn. So now O is playing, and they may put in a piece, let's say A4. All right, now it's X's turn, and I'll go D1, and then it's O's turn, and I'll do C4. We're not very smart here, and then I'll do G1. And notice now I have formed a mill. I got 3 in a row here in the X's. Now notice it says I get to remove a piece. All right. So let's remove a piece. I have got 2 to choose from. Let's remove the one in A4. And now you see that that I have removed the piece in A4, and we continue on in the game that way. And that's how the game is played. And we can type a Q at any point and quit it, or we can type help and get the instructions. We can type an R and restart the game, and we can quit it, or I'm putting things in there. So so we give you the class. Here's what the class looks like. It is a board class. Okay, it has 2 sets of constants here that are helpful. This one shows all the adjacencies. So for example, if I'm at location A1, who's adjacent to me? Oh, D1 and A4 are, right? So if I'm at A1, if I'm at this spot, then adjacent one here is the D1. So we see a D1, and the adjacent one along the other side, so that was adjacent that way. The adjacent one on the other side is A4. That's A4. So this is a dictionary where the keys are locations, and then there's a list of who's adjacent to it. And that's, so now when I'm in the moving phase, and somebody puts in specifies a location, I can very quickly use this to check to see whether that is in fact an adjacent one. And the same thing here with mills. Okay, so here is a mill, and it's these three: the A1, the D1, and the G1. All right. Here's another mill: B2, D2, F2. Let's take a look at that. If I have B2, D2, and F2, so B2, D2, and F2. So those three make a mill. That's what's in there. So again, it's this. We're giving you this. This will make your life a little easier. Have I formed a mill? You've got all the possible mills. We already did that for you. And then the attribute of this thing of a board is again another dictionary, and each location, A1 for example here, initially is a blank. All right. And then there's I can assign a piece, I can clear a piece, and then there's the SDR. So that means that I can do a print of this. That prints the board with whatever values are in this attribute points. So let me illustrate there, and I can do this in the shell. 9 mens Morris, okay, and I can create a board, and that's 9 mens Morris class board. That creates one. And I can print that, right? And that prints an empty board. And what can I do? I can go I can assign something to I can assign an X to a particular location. Let's assign one to D7. All right, and then if I print the board, there it is. We see that there is an X has shown up at that location. And then I can also, so that was using this method. And then I want to clear, so if I'm removing one, so I can then say my board clear a place, and let's clear D7 since that has something in it. And when I print the board, we see that I just removed the piece that was in there. Now, one of the characteristics of this class that we have is that there is no underscore in front of that, right? When we put the double underscore in front of it, that makes it private. And this one is not, so I can access things. So I can say, let me go back here. Let me put the X back in there. And now I can say something like board.points D7, is that equal to the character X? And it's true. Okay. Is it equal to my O? false. So I can check that way whether a particular value is in there, and I can go around the board and say, oh, maybe G7, is that an O? No, because G7 was blank. Right? So I have the capability of doing things like that because, and the reason is that the way my points is set up is that at a particular key, the value is one character. So that means that this thing right here is one character. All right. And so I have a character on the left of my double equal sign, and I have a character on the right. And that's, so board points of a particular item, D7 right there, that is a character. So it is a character equal to character. So what we're doing here is we're manipulating characters. That's all we're doing. And so you need to think about that. I'm just checking to see whether I have X's, zeros, or blanks in these things, and I'm checking to see if they're in a row. How do I know if they're in a row? Oh, well, I've got my mills here, which helps me out with that. When I do the adjacency stuff, when I'm moving things around, who's it? I'm in a particular position, and like a 7, and it's who's adjacent to it, right? And so these are the types of things that that are helpful to you to actually build this game. And we give you a skeleton like we've been doing. And there's a bunch of functions there. We give you one. We give you a lot of the main routine, and in there you see like a pass. So you're going to have to replace that with some good stuff. We start out with phase 1 loop, and then below that is a phase 2 loop. We've given you a lot of it, and again, there's a pass to be in there. By the way, just I still see code with pass still left in there. You should really be deleting that. It works to leave it there, but it just clutters your code, makes it harder to read. And we've just got a bunch of functions. This one we already gave you. You haven't seen a statement like that. All right, this will return X if player equals O. Otherwise, it will return the O. Okay, a little different format. We haven't seen that one, so we thought we'd throw it in there so you can see an instruction like that. And then there's just a bunch of little functions. Unfortunately, because these have to be, because there's a prompt for that will be part of this function to remove a piece. Remember, we got to remove a piece. We'll prompt for that. We can't do an individual function test for that or the ones that call it. And so there's a clue for you. The ones that we don't have tests on, at some point, call removing a piece. So a little bit of clue for you there, just in terms of how we set it up. All right, hopefully that gives you enough to get started.